Hello, Geometry Advanced students. This is Coach DePaulo, and this is a video for lesson 5.2. It's our second lesson of this chapter, and it's our second to last lesson of this chapter. This is another short chapter. It will be over before you know it. So let's go ahead and get started. Last time we were together, we talked about isosceles and equilateral triangles. And today we're going to be talking about some properties. So we're going to talk about the triangle inequality property. We're going to talk about the Pythagorean theorem, but we're going to take its converse. And then we're going to talk about remote exterior angles. Now this, I will tell you in advance that this lesson is long. So if I were you and I was watching this, I'd break it up into two parts. The notes are 4 pages. So I would probably do 2 pages of the notes, go to the assignment, try to go ahead and work on it, and then come back, finish the notes, and then go to the rest of the assignment. So let's go ahead and get started. So this first, I have an activity to start off with, and the activity says to use a ruler and draw a triangle with side lengths of 3 and 4 and 5. Okay, so first thing I'm going to do is I pulled out my ruler, and I'm going to draw a length of 5 right there. And if I had 2 rulers, it would probably be easier to show. But I'm going to go ahead and turn this ruler to the side, and I'm going to bring this down here, and I'm going to draw a side of 3. Now my first side's not quite long enough, or sorry, it started off too tall. So let me start over again, and let me draw a line that's 5 units long. And then I'm going to turn this over here, and I'm going to draw one that's 3 units long. And let's see, let me try to get this perfect right there. There we go. So here's 3 units long. And then I'm going to turn this and diagonally go, and turns out that, wait a minute, I can't make it with a 4. So let's try this. Let's try to put the 4 down here at the bottom. All right, so here, oops. Let's try to go to this 4 right here. And now let's turn it, and sure enough, there we go, it fits. And so now I can draw the 5. All right, so there's my 3, 4, 5 triangle, and it fits. I've got a triangle. Okay, so this is 3 units, and this is 4 units, and this is 5 units. All right, so let me come over here, and let me do the same thing. I'm going to come over here, and I'm going to put my 4 down at the bottom. There we go, and put my 4 down here. And then I'm going to put my 3 on the side. All right, and then I'm going to come over here, turn this, I need an 8. So let's see. Whoa, that is like way too short. My 8 goes all the way out there. I can't do that. So what I need to do then, I guess, is let me erase, and let me come over here, and let me put the 4 here. And then what I'm going to do is I'm going to make my 3, and I'm going to turn it sideways like that, maybe open it up a little bit. All right, now the 8 should fit, right? Oh gosh, it still doesn't fit. So maybe I need to make the 3, I need to make this a little flatter. So let me try this. Let me try the 3 here. And now surely my 8 will fit, right? and it turns out that it almost fits, but it's not quite there. So the last thing that I can do is, let me see, let me make sure this is 4 again. So I'm going to start at the 4, and I'm going to go to the 0. All right, and then I'm going to make my 3, and there we go. And then I'm going to make my 8. Oh, but look, it's too long. So I can't make a triangle with the 3, right? Because here was the 3, and here was the 4, and here was the 8. So I can't make one. So based on your drawings, what can you conclude? So I want y'all to write real quick. What do you think this means? So hopefully while thinking about it, you can find out, and this is called the triangle inequality theorem, and it says that the sum of the lengths of any two sides of the triangle is greater than the length of the third side. So, and you can look back over here and you can see that since the third side was too long for the other two sides, then it won't fit. Okay, so what happens though, if I had said, you know what, I'm gonna, instead of an 8, I had a 6, since 3 and 4 are longer than 6, then that would have made a triangle. All right, so let's go over here and let's see, will the following 3 lengths of a triangle fit? So what we can do is we can always take the shortest 2 sides and add them up. 4 plus 7, and that is equal to 11. Okay, so I'm going to say 11 is not greater than 11, so not a triangle. It has to be greater. Okay, so what would have happened up here then with my 4 and my 7 is the 4 and the 7. So what would end up happening, and this is not going to be exact, but what would have happened was I'd have my 4 here, and then I'd have my 7 I'd have my 7 here, and then what would happen is it would be exactly like that. So there's no angles at all. It would end up being exactly the same length, so no triangle. Okay, so then let's go over here. We're going to take the 2, we're going to add the 5, and that's going to be 7. 7 is not greater than 9, so again, this is not a triangle. And then we're going to come over here, we're going to take the 2 smallest ones, 10 and 14, and that's 24, and 24 is greater than 15, so this is a triangle. And you can always take the 2 smallest ones and add them up, and they got to be bigger than the largest one. Okay, all right. So then what we can also do is we can also find a range of numbers. Okay, and so if we find the range, in order to find the range of numbers, what we're going to do is we're going to compare the 2 sides that I've been given, and say, okay, given these 2 lengths, what's the smallest that the third side could be, and what's the largest that the third side could be, and then x is going to be in between that range. Okay, so turns out that it's an easy process. If I take 14 and subtract 6, that's 8. So I know that x has to be greater than 8. And if I take 14 and add 6, I get 20. So I know that x has to be less than 20. So then when you combine those, we put x in the middle. 8 has to be less than x, which has to be less than 20. All right, and then a kind of a shortcut, if you want to look at it, you can put x in the middle. We always have 2 less than signs. This is going to be the 2 numbers subtracted, and this is going to be the two numbers added together. All right, so if three sides of a triangle are 4, 10, and x, what's the possible range? Okay, so what I'm going to do is I'm going to put x in the middle. I got two less than symbols. Okay, and then 10 minus 4 is 6. So this is 6. And 10 plus 4 is 14. So this is 14. So x has to be somewhere between 6 and 14. It has to be greater than 6, but less than 14. All right, same thing here. I'm going to put x in the middle, two less than signs. So 6 plus 9 is 15, so that goes here. And 9 minus 6 is 3, so that goes there. So there is my range. Okay, so we are almost done with the second page. And so like I said earlier, what I want you to do is when we get to the bottom of this page, I want you to pause the video. I want you to go and start the assignment, and you can start the assignment with the first 2 or 3 topics that we've discussed, and then you could come back to the video. Okay, next up, we are going to look at the Pythagorean theorem, but we're going to use it in a different way. Before today, we've always said that if a triangle is a right triangle, then we can use the Pythagorean theorem to find a missing side. So just real quick over here on the side, I'll draw a right triangle, and I'll say, okay, this is 4, and this is, say, 7, and what is x? And what we did was we said 4 squared plus 7 squared equals x squared. So 16 plus 49 is x squared, and then 14 plus 49 is 65. So then x was the square root of 65. And so we've been using the Pythagorean theorem for that for quite a long time. But now what we're going to do is we're going to determine what type of triangle we have using the Pythagorean theorem. So we're going to know all the sides, but we're going to figure out, using the Pythagorean theorem, if the 3 sides put together form a right triangle, an obtuse triangle, or an acute triangle. So let's go ahead and look. So over here on this chart, in advance, I'm telling you, if you put a 5 and an 8 and a 9 together, that it's going to be an acute triangle. So let's see what we can look at. So the 2 smallest sides are going to be 5 squared plus 8 squared. Okay, and 5 squared is 25, and 8 squared is 64. And so this is equal to, 5 squared is 25, and 64, so that is 80, 93. And 9 squared is 81. And so we have 93 is greater than 81. All right, and then let's look at the next one. The next one is also acute. We've got 7 squared plus 12 squared. That's 49 plus 144. So that's going to be 143 plus 50, so 183. That'd be 193, sorry. And then we've got 13 squared, which is 169, and that is greater again. All right, let's look at an obtuse triangle. Okay, so an obtuse triangle, we've got 8 squared plus 11 squared, and over here we've got 14 squared. So 64 plus 121 is 185, and 14 squared is 196. So this time we got a less. Okay, and then let's look here. We got a 9 squared plus a 12 squared, And over here we got a 16 squared. While I'm here, this is 256. And this is 81 plus 144. So what's that, 225? All right, and 225 again is less than 256. And lastly, we got a right triangle. We got a 6 squared plus an 8 squared. That's 36 plus 64, which is 100. And over here we got 10 squared, which is also 100, and that's equal. Now, I'm going to turn all these a different color just so that they stick out just a little bit better on what we're actually comparing. So we're comparing the red to the blue. All right, let's see. Apologize for the delay here. I should have done this as we were going. Okay, so let's see, is there a relationship that you can find between a squared plus b squared and the c squared? Can you see the relationship? And hopefully we can see, right, that right here on the, well, what I'm asking you to do is look here. These were the two acutes. So look there. Okay, these were the two obtuse. So look there. And this was the right triangle. And now what I want to do is I want to take these and I want us to look at it in the opposite direction than normal. So what I want you to do is, instead of looking at the Pythagorean theorem this way, a squared plus b squared equals c squared, I want you to turn it around and I want you to have c squared, and I want you to compare that to a squared plus b squared. So let's look back up here. When was C greater than A and B? So that was right here. Here is C being 196 and it's greater than 185. Here is C being 256 and greater than 225. And that's when a triangle was obtuse. Okay, and then when was it less than? So right here, 81 was less than 93, 169 was less than 193. So when the triangle was acute, the C was less. And then when was it equal? Right here, we have 100 is equal to 100, and that was when it was a right triangle. Okay. And we put it backwards mainly because whenever we think of the word greater, out of the two types of triangles, obtuse and acute, greater we tend to think of as bigger, and obtuse we think of bigger angles, right? So obtuse is greater than 90, acute is less than 90. And so we turned it around so that the greater than symbol would make it obtuse and the less than symbol would make it acute. All right, so let's look and see over here. So we're going to take our biggest number, which is 20, and we're going to square that, and we're going to compare it to 8 squared and 18 squared. Okay, so 20 squared is 400. And let's compare that to 8 squared plus 18 squared, which is 388. So that is greater. So since it's greater, then if you put these three sides together, that would be an obtuse triangle. Now, what I'd like you to do, though, before you even do that, is let's test. Is 8 plus 18 greater than 20? And it is. So we got to even make sure that it's a triangle to begin with. And it is. It is a triangle. Okay, so let's look up here. 1.6 plus 6.3, that is greater than 6.5. So it is a triangle. And now let's see what kind. So 6.5 squared. We're going to compare that to 1.6 squared plus 6.3 squared. So 6.5 squared is 42.25, and 1.6 squared plus 6.3 squared is 42.25. So this is equal. So then that means that these three sides are the sides of a right triangle. All right, and then over here, let's test this one. Let's see. First off, the square root of 31 is 5.6, or around 5.6. So that's the smallest side. So we need to ask ourselves, is 5.6 plus 15 greater than 16? And it is. So these are the three sides of a triangle. But the two we need to put together are, let's see, this. We're going to take the 16, that's our biggest side, and we're going to compare it to the square root of 31 squared plus 15 squared. And let's see, 16 squared is 256, and the square root of 31 squared plus 15 squared is 256. So we have another right triangle. Okay? So let's go and look here. Well, first off, I want you to pause the video right here, and I want you to go back to, or go to your assignment, 5.2 practice, and I want you to work on the triangle inequality problems, determining if three sides make a triangle, then determining what range, if you're given two sides of a triangle, determining what range you could have, and then also look at the Pythagorean theorem, and decide on what types of triangles you have given three sides. Then I want you to pause the video here, go work on that, and then come back. Okay, so let's move on to the next part of our notes, and that's going to be, we're going to be talking about comparing angles and sides, and what's the relationship between the angles inside a triangle and its side lengths. So first over here, let's list our angles in order from least to greatest. So our angles in order from least to greatest would be 37 degrees, 60 degrees, and 83 degrees. Okay, now we're going to list the sides in order from least to greatest. And the sides from least to greatest are 2.5 and 3.8 and 4.3. And so what I want us to do is I want us to compare the longest side and the largest angle. So I'm going to circle those. Here's the longest side and the largest angle. And what do you know? They're both last in my list from least to greatest. And then what's first? Well, the smallest side is first, right along with the smallest angle. And then right there in the middle, the medium size angle is second, right along with the medium size side. So what can we, and so we just kind of did 10 right there, 10A and 10B. So if we compare the largest side and the longest angle, they're opposite each other. Okay, they are opposites. They are opposite each other. Now, what do I mean by that? So what I want you to do is put your pencil on the largest angle. And I want you to draw a line diagonal through the center of the triangle, and where you end up is on the longest side. I want you to do the same thing with the shortest. Put your pencil at the corner of the shortest angle, draw a diagonal line through the middle of the triangle, and what do you know? I end up on the shortest side. Okay, so again, I can use the power of my little project, or my little software here, and I can just copy and paste. They are opposite each other. Okay, so write a conjecture about the relationship of the interior angles and the sides opposite them. All right, so I want you to make sure you leave yourself room. We're going to write 3 different items in here. So first thing we're going to write is largest angle is opposite longest side. Medium angle is opposite medium side. And smallest angle is opposite shortest side. And then down here for the conjecture, write a conjecture about the relationships of the sides to the interior angles opposite them. And then what we can say here is that these statements are the converse of above. So we're going to start with largest or longest side is opposite largest angle. Medium side is opposite medium angle. And shortest side is opposite smallest angle. Okay, so here we go. A landscape architect is designing a triangular deck. She wants to place benches in the largest corner. In which corner should she place the benches? So we know that this angle will be the smallest angle because it's opposite the 18. This angle will be the medium, and this angle will be the largest because it's opposite the largest side. So we're going to say the benches go in the corner marked angle C. All right, in triangle RST, R is 50 and S is 60. List the sides of the triangle in order from shortest to longest. Okay, so this does not have to be drawn to scale. Okay, so I'm just going to draw any kind of triangle. I'm going to call this R and S and T. And we know that R is 50. We know that S is 60. That's 110. So then that must mean that T is 70. All right, and so list the sides in order from shortest to longest. So I need smallest angle is opposite shortest side. So then I've got 50 goes towards the ST, so that's going to be the shortest side. And then the 60 goes to RT, so that's going to be the medium side. And then the largest angle is opposite of RS or SR, and so that's going to be the longest side. All right, list the angles of triangle CUP, CUP, in order from largest to smallest. Okay, so first we are going to use the Pythagorean theorem, and we're going to say 7 squared plus x squared equals 25 squared. This is going to be x. So this is 49 plus x squared equals 625. And 625 minus 49 is 576. And so x is 24. So list the angles in order. So the largest angle is going to be the 90 because it's opposite the 25. So we're going to have angle U. And then the 24 is opposite C. So this is going to be angle C, then which leads angle P is the smallest. All right, so here we go. Find the longest and shortest sides in each of these diagrams. So let's start off with triangle STQ. If I got a 90 and a 30, that makes this a 60 degree. And 75 plus 45 is 120. That makes this a 60 degree. Okay, so now let's look at these sides. So I'm going to write a number 1 on the shortest side. This is the medium, and this is the longest side. And then in this triangle, this is the shortest side, this is the medium, and this is the longest. So the longest side has to be the TR. And why is that? Well, the longest side of the triangle STQ is the shortest side of TQ in the big triangle. So that must mean that the longest side in TQR is the longest of the two triangles. Then the shortest side is going to be ST because it is the shortest side of the smallest triangle. All right, let's go over here. What do we got? We got 75 and 35 is 110, which makes this 70. So then this is the shortest, the medium, and the longest. And then over here, 70 plus 45 is 115, and 180 minus 115 is 65. So that must mean that this is the shortest, this is the medium, and this is the longest. So the longest side of these two triangles has got to be SR, because the longest side of the SPQ is the shortest of SQR. So that must mean SR is the longest, which would put PS as the shortest. All right, we've got one more page of notes, but I'd like you to go ahead and pause right here real quick. Go do some more homework and come on back. Okay, so our last topic of today is the triangle exterior angle theorem, or otherwise known as the remote exterior angle theorem. Okay, so first off, let's remind ourselves that the sum of the interior angles of a triangle is 180 degrees. And so in this picture, right over here, we have four angles. Angle 1, angle 2, and angle 3 are the angles of the triangle cup. And angle 4 is an exterior angle, right? So let's go ahead and label those. Angle 4 is the exterior angle. The interior angle that's adjacent to that is angle 1. Because remember, adjacent means to touch. So angle 4 right here touches angle 1, and they share a side. They share UP as a side. All right, so then the two remote interior angles, meaning they are the two angles, what I used to say, farthest from angle 4. So the two angles farthest from angle 4 are angle 2 and angle 3. All right, now, there's a little video that I do not have access to, and it's going to be on Canvas, and it's at the very beginning of this video. You're going to see this demonstration of patty paper, but I'm going to do the same thing kind of mathematically, okay? So here's what I'm looking at. I want to find out how big is angle 4, okay? So if I look at angle 4, I know that angle 1 plus angle 4 is 180 degrees. So I know that angle 4 is equal to 180 minus the measure of angle 1. Now, and again, I'm doing this really small, but what do I know about the measure of angle 1 and angle 2 and angle 3? Okay, now, to be mathematically correct, I'm going to go back here, and I need to write measure. Okay, so the measure of angle 1 plus the measure of angle 4 is 180. So the measure of angle 4 is 180 minus the measure of angle 1. Okay, now, over here, what do we got? Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. And I'm going to move that measure of angle 1 to the other side again. The measure of angle 2 plus the measure of angle 3 is equal to 180 minus the measure of angle 1. All right, now let me try to make this look a little bit neater. The measure of angle 1. So what I want you to notice is that the exterior angle, angle 4, is 180 minus the measure of angle 1, right here. And the measure of angle 2 and 3 are also 180 minus the measure of angle 1. So that's what the exterior angle theorem says. The exterior angle theorem says that the exterior angle of a triangle is equal to the sum of the two remote interior angles. All right, so I want just to look and find these values. Okay, so we're going to use the remote angle theorem, and we're going to say here, this is the exterior angle. And we're going to say that the measure of angle X is equal to the sum of the two remotes. So it's 61 plus 39. So the measure of angle X is equal to 100 degrees. Okay, let's go over here to number 21. Now, what I want to do is I need to find this angle over here. Okay, I need to find the measure of this angle over here. So the first thing I'm going to do is I'm going to use my adjacent angle, or my linear pair rules. Since this is 110 and together they add up to 180, this has got to be 70. Okay, these two right here are vertical, so this is 57 degrees. All right, and so I now am going to say that the measure of angle y plus 10 is equal to 70 plus 57. So the measure of angle y plus 10 is equal to 127. So now y has got to be 117. All right, so now let's go ahead and try to find the measure of angle x. That's our exterior angle. So using our linear pair rules, I know that this has got to be 32 degrees because that adds up to 180. Okay, and then I'm going to take this triangle is 180, so I'm going to take 180 and I'm going to subtract 95 and 32, so this is 53. Okay, so that means this is also 53 because they're congruent. Okay, I know that these two angles right here are a linear pair, so then 180 minus 95 is 85. Okay, and now these two are the remote interior angles from x. So then I can say that the measure of angle x is equal to 53 plus 85. So the measure of angle x is equal to 85 plus 53, which is 138 degrees. All right, number 23, I've got 5x plus 50 equals 3x plus 7x. So 5x plus 50 is equal to 10x. Subtract 5x from both sides, so 50 is equal to 5x. Divide both sides by 5, and so x is equal to 10. All right, and then lastly it says find the value of x and list the angles in order from greatest to least. So I know these all add up to 180. So I have 9x plus 29 plus 93 minus 5x plus 10x plus 2 equals 180. I'm going to combine the 9 and the negative 5 and the 10, and that's going to be 14x. And then I'm going to combine the 29 and the 93. So that's going to be 122. And then I'm going to add 2 more. So that's going to be 124 equals 180. So 14x is equal to 180 minus 124, which is 56. And so that means that divide that by 14. So x is 4. Okay, and then we're going to go 9 times 4 is 36 plus 29. So this is 65 degrees. 93 minus 5 times 4 is 73 degrees. And 10 times 4 is 40 plus 2 is 42 degrees. So this is the shortest, this is the medium, and this is the longest side. So list the sides in order from greatest to least. So that'll be BC, then AC, then AB. All right. So that is our notes for today. And next up is practice 5.2. So hopefully you have started most of this and you're probably hopefully 2/3 of the way done. And if you have any questions, come on in for some tutoring, and hope y'all have a great day.